All right, so predicting the relative electronegativities of atoms. So electronegativity is basically the ability of an atom to pull electrons towards itself in a bond. So like ability to pull electrons towards itself. So something that has slightly more of a positive charge is going to be better at pulling negatively charged electrons towards itself. So actually electronegativity does trend with effective nuclear charge, and we already know those trends, right? So we know that effective nuclear charge is going to increase across a period because we have the same amount of shielding across a period, because you're adding electrons in the same valence shell, but the amount of nuclear charge is going up by 1 as you increase the atomic number each time. So because there's less shielding between the nucleus and those outer electrons that you are adding, um, then those outer valence electrons are experiencing a higher amount of effective nuclear charge, which is why atomic radius decreases as you go across a period. So if your effective nuclear charge is increasing, your electronegativity is also increasing, up to fluorine. Obviously, the noble gases, because they've got complete shells, aren't attracting any electrons towards themselves in particular, because there's that charge balance there. And we see the same trend going down a group, right? So as you go down a group, your outer electrons are further away from the nucleus, okay? So you are seeing effective nuclear charge decrease, generally speaking. So we should be seeing electronegativity decreasing. So the electronegativity is highest towards the top right-hand side of the periodic table, okay? So fluorine is the most electronegative element. Francium would be like the least electronegative element, okay? You can also use the actual electronegativity values, okay? So these are like Pauling electronegativity values, which you usually get in your textbook or whatever. So you can see the general trends are mostly followed, okay? And you can have actual numbers associated with that. But we're going to just kind of try and stick to periodic trends as much as possible rather than actually using numbers, okay? So we're asked to reorder this list from the most electronegative to the least electronegative. So let's find all these elements on the periodic table. So nitrogen, phosphorus, and arsenic. Nitrogen, phosphorus, and arsenic. They're all in the same group. Okay, so nitrogen is going to be more electronegative than phosphorus, and phosphorus is going to be more electronegative than arsenic. So nitrogen, most electronegative, then phosphorus, then arsenic. Okay, so what about nitrogen, carbon, and silicon? Well, here's nitrogen, here's carbon, here's silicon. Okay, so we might want to sort of do a little relative order and then paste that together. Okay, so we know that nitrogen is going to be more electronegative than carbon, because nitrogen's to the right of carbon. We also know that carbon is going to be more electronegative than silicon, okay? So we should be able to sort of paste that together now, okay? So we can combine our findings to say nitrogen is the most electronegative, then carbon, and then silicon, okay? So if you're like, oh, I can't do it in once, just pick two that sort of find the similarities, find the difference, and then kind of paste that together. Alternatively, you could have also just looked at the electronegativity values, but you might not always have that, right? So it's good to sort of understand where the trends come from and not just look at numbers.